my amazing students. This is Mrs. A, and I am in my car trying to give you a little bit of help on 2.4 before some of you take a test tomorrow. So I'm trying to get this done and get this posted. Likely it's not going to be very pretty. I'm probably going to be working on my notebook paper, but I will be at least explaining the process. So this one, you're going to see more of the paper than anything else, but hopefully it will be enough to give you an idea of what's going on so that you'll be prepared for even and odd functions and symmetry tomorrow on your test. Okay, on 2.4 exercise set, let's just look through some of these graphs that they have here. You see this one right here is an even function because it is y-axis symmetry, and y-axis symmetry is implying an even function. Okay, what is y-axis symmetry? It's saying that if I have f of x, it's going to be the same thing as f of negative x. And remember, the f is your y, so the y value at 2 will be the same as the y value at negative 2 on this graph. So it is y-symmetric and it is even. Okay, look at this graph right here. Can you see how this height right here, this f of x, is the same thing as f of negative x? That changing from one side of the axis to the other is not affecting the y value at all. So this again is an even function and it is y-symmetric. Notice that it is not symmetric about the x-axis. If you flipped it across the x-axis, it would not look the same. But if you flipped it across the y-axis, it would map onto itself. Okay, look at this one. This one is having an axis of symmetry that is the x-axis here. So the x-axis is going right down through this absolute value. Okay, so this is an x-axis symmetry, and because it's x-axis and not y and not origin, it is not going to be even or odd or neither. I mean, it's going to be neither either nor odd, but it is x-axis symmetry. All right, what about this one? Okay, this one is not symmetric about the x-axis or the y-axis, but it is symmetric about the origin. If you put a little pin right there at the origin and you spun it around 180 degrees, it would lie back on itself. So this one is origin symmetry, and because it's origin symmetry, it is odd. Okay, let's look at this one up here on the top. Okay, looking at it here, let's kind of analyze it a little bit. If you were to spin it 180 degrees, would it go back on itself? Okay, and from what I'm looking at, that one is origin symmetry, and because it's origin symmetry, it would be odd. All right, now what is the trademark for odd? F of negative x is the same thing as the negative of f of x. So if we plugged in the function at a negative 2, okay, so let's say this right here is the function at a negative 2, then it would be the opposite of the function at positive 2. And so if this one was maybe a y of negative 3, then this one would be a y of positive 3. And so that meets that criteria of being an odd function. Okay, so let's look at this one. Ooh, that's weird. Okay, so this one has x-axis and y-axis symmetry. Now, does it also have origin symmetry? If we took it and rotated it 180 degrees, would it be back on top of itself? And it looks like it. So this one is x-axis, y-axis, and origin. Therefore, this is one of those weirdos that is both even and odd. Okay, because it's got y-axis symmetry, it is even, and because it's got origin symmetry, it qualifies as odd. So it's everything. That one's everything. Okay, so now we're going to start working at some of these problems in a moment. Okay, so this problem, y is the absolute value of x minus 2. All right, now I did go ahead and I'm trying to show you algebraically, if you plug in f of negative x, that means everywhere you see an x, you're going to replace it with a negative x. Then you get this, which because of the absolute value turns back into this and has no effect on the function. Therefore, since you can replace x with negative x, you have y-axis symmetry. And then I plugged in a y with the negative y, but that changed the left-hand side, but not the right side. Therefore, it was not the same as the original. I changed both out. If I change both, then this one does not affect, and that one does affect, so you don't wind up with the same thing. So it's only y-axis symmetry. Because it is y-axis symmetry, it is also what? Y-axis implies an even function. So this was y-axis symmetry and even. Okay, so now we have x squared plus 4 is 3y. And notice that on the board I replaced y with negative y. And when I did that, it's only going to change the right-hand side of the equation. Okay, well, only changing the right-hand side does not work for keeping it the same. We have to change all signs if we're going to change one of them. So that one didn't work. Okay, so then I replaced the x with the negative x, and there was no change because the x squared would square out the negative x. So there was no change in the equation, which meant that if I could replace the x with negative x, then that was y-axis symmetry. And then, lastly, I replaced them both, and it was not the same. When I replaced them both, the y side changed, but the x side didn't, leaving me with a different equation. So, it was only y-axis symmetric, and y-axis symmetry is corresponding with even. So this was y-axis symmetry, and it could be categorized as an even function. All right, so now we have an interesting one. 6x plus 7y is equal to 0. Now, when we look at it, we've got, when we replace x with negative x, then this part's going to change signs, but not this part, okay? We replace y with negative y, that doesn't work either, because only one part of the equation changes. What about if I replace both? Okay, if I replace the x with the negative x, and the y with the negative y, then I'm changing both signs at the same time, which winds up being symmetric about the origin. We could get rid of that negative sign that is now in common between the both parts. So if you look at the equation, it actually turns into the equation of a line that has a negative slope. So this is a y is equal to negative 6 over 7x. Since there is no y-intercept, that means it goes through 0, 0 at a negative slope of 6/7. And then if we were to rotate it on its axis 180 degrees, then it would be the same line. So therefore, this one is origin symmetric only. Okay, because only replacing both the x and the y at the same time made it go back to the original equation, and it is, since it's origin, it is odd. Okay, and odd means that f of negative x, which would be this value right here, is going to be the same as f of positive x with the opposite sign, so negative f of x. So the trademark for odd is f of negative x is the same thing as opposite of f of x. And that was number 16. Okay, so this one is interesting. If I take 2x to the fourth plus 3 as y squared, and I replace the x with a negative x, it has no effect at all. I have the same equation back again, so my equation is symmetric about the y-axis. If I also replace the y with a negative y, then the equation undergoes no change whatsoever because the negative gets squared out and I have symmetry about the x-axis. If I likewise replace both at the same time, x with negative x and y with negative y, then I get back to my original equation again. So I have origin symmetry. Now, if you actually look at this little graph down here, this is an approximate of what this graph looks like. This is not a circle, it's a hyperbola, and it's going to look something like that. Okay, and because of that, can you see the x-axis symmetry here and the y-axis symmetry here? And can you see that if you rotated it, it would also be symmetric about the origin? So, since this one has all three types of symmetries, this is one of those weird ones that would categorize as even and odd. It characterizes as both because when you look at the graph, f of negative x, let me get this to stick here, f of negative x is the same as f of x, but f of negative x is also the opposite. So f of the y value, there's two y values, right? So the y value, f of negative x, could be, say, negative 3 here, but it could also be positive 3, which would be the opposite of this one over here. So it winds up meeting the characteristics of both. Okay, so here we have another equation. This is number 26 in your textbook. When I replace x with negative x, it does not work. I do not get the same equation. If I replace y with a negative y, it does not work. But if I replace them both at the same time, then all of a sudden I go back to my original equation. So I have origin symmetry, which means that my function is an odd function. Okay, so now we are working on what happens to the actual points as we move from an original point. Here I have 3 original points, and then we're talking about what happens when we reflect them across the x-axis, the y-axis, and the origin. Okay, so that you could check these points. If you were looking for x-axis symmetry and negative 5, 6 was on your graph, you remember x-axis symmetry occurs when we can change the y with the negative y and still have the same function. So when we have x-axis symmetry, the y's will change, not the x's. When we have y-axis symmetry, our x's will change. And when we have origin symmetry, they both change. Okay, so this is just an example of what's happening to as you're reflecting across the x-axis, y-axis, and the origin. So if negative 10, negative 7 was your original point, and you were reflecting across the x-axis, then your y would change. Okay, if you're reflecting the same point across the y-axis, then your x would change. And if you're reflecting this point across the origin, or twisting it around the origin actually, then both of them will change signs. Okay, so 8, negative 3 changes the y, changes the x for the y-axis origin and symmetry, and then changes both signs for the origin. That's also a good check to see if you're ever in doubt on whether your function is even or odd. You can do these little tests. Okay, so now I've got the little camera looking at 33, 34, 35, 36, 37, 38, which are pictures. Okay, when you're looking at 33, we're trying to decide whether these are even or odd, and you can see that 33 has y-axis symmetry, therefore it is even. And 34 has y-axis symmetry, and therefore it is even. 35, okay, now let's look a little closer at 35, all right? You can see that it's not the same on both sides of the x-axis. It is not the same on both sides of the y-axis. But if you put a pinwheel in the middle and you rotate it 180 degrees, you would lie back, the function would lie back on itself. Therefore, it has origin symmetry and is odd. Okay, this one is neither, because we have the little darkened point here and the empty open point there. And so even though it has kind of an odd configuration, it's not exactly odd because of those two little points there. Okay, the same thing is with this one. It would be odd because it would rotate about the origin, but because one is a dark circle and one is an open circle, it's a neither. And this one does not go through the origin at all. Remember, the odd must be symmetric about the origin, and the even must be symmetric about the y-axis, and this one is obviously neither. Okay, so we're going to do just a few more, and we're going to close this video down. Okay, so this one is one we're going to evaluate for even, odd, or neither. Now remember that if it is even, then I can replace x with negative x and nothing happens. In other words, I have y-axis symmetry. If it's odd, I am going to get exactly the opposite. All right, well, we can see that if we replace x with negative x here, that's going to change sign, and that's going to change sign. That one's not going to change sign. It's not going to be the same function, right? The y will stay positive, but everything else, two of those change. That's not going to work. So it is not y-axis symmetry. If I replace the x with a negative x here, and the x with a negative x here, these are both going to change signs. But what about that negative 2? That stays the same. Okay, so basically for f of negative x to be the same thing as f of x, then, I mean, negative f of x, that's the odd definition right there, isn't it? For f of negative x to be the same as the opposite, then every single sign must change. This one changes and this one changes, but that constant 2 does not change. Therefore, this one is neither even nor odd. This is neither. Okay, so let's analyze number 45, and I think this will be the last one that we do. So we know that if we change x with negative x, that one will change, but that one won't change. So we don't get a constant change, therefore it's not symmetric about the y. Okay, if we change the y with the negative y, this one will change, but then the right-hand side does not change. Okay, so we don't have x-axis symmetry either. If we change both the x and the y, all right, so we're going to have this one change here. If we change the y, that one will change. We change the x, that one will change. But this sign is going to stay the same. And again, we don't get back to our original equation. Okay, so if we are looking at this one and we changed everything, both of them at the same time, we don't get back. So this one is just neither. This one is neither even nor odd. Okay, so we're going to do 42 real quickly. And 42 is f of x is equal to x plus 1 over x. Okay, this is the last one we're going to do. We're going to call it done. All right, so let's analyze this one. If we replace x with negative x, that one becomes negative. X with negative x, that one becomes negative. So one side stays positive, one side goes negative. That is the definition of an odd function, isn't it? F of negative x is the same thing as the opposite of f of x. So this one looks like it is going to be odd, all right? And since it's odd, it is going to, that's going to reflect about the what? The origin. Odds reflect about the origin, or origin symmetry. If I replace this one and this one and this one, then I end up getting the same function back again. And that's my origin symmetry. Okay, it doesn't have our x-axis symmetry. It doesn't have our y-axis symmetry, but it does have origin symmetry, and therefore it is odd. And this concludes our video on 2.4, and you are now ready for your test. And I will see you soon on test day. And this is Mrs. A, and may God bless your day.